My private key is 0x257A 6941. Okay, everyone's listening intently. That's good. Okay, yeah. So today I wanted to talk about something that's like different from what I talked about last year, but still, within the range of things that I talk about often, which is just like some thoughts on the longer-term future of where Ethereum is going as a protocol, right? So here, not just to the ecosystem, but like specifically the blockchain and kind of the core infrastructure around the blockchain, the consensus, and just what do we expect that side of things to look 10 years from now, and how can we start now to build toward something that actually would be an Ethereum protocol that we would want to see in the long term. So the Ethereum protocol right now is in the middle of this long and complicated transition. And it's a transition toward becoming a system which is much more powerful and robust in a lot of ways, right? So at the end of the last year, I published this kind of updated roadmap document where we talked about these kind of big 5 categories of like stuff that's happening in Ethereum protocol lands, right? Where there's the merge, the surge, the verge, and then a bit lower is going to be the purge and the splurge, right? So the merge is proof of stake, the surge is sharding, and the verge is Vertical trees. The purge is like things like state expiry and like deleting old history, and the splurge is basically just all of the other fun stuff. So there's a lot to do in each of these categories, right? So like in the merge, for example, we fork choice improvements. Actually, I think this little square should be completely full now. Test networks, this one should be like probably 90% full, because the only thing left to do is to do a merge on Robston, which should happen quite soon. And then, merge. And post-merge, obviously enabling withdrawals so that people who actually just started staking would actually be able to get their money back. But then there's also these like interesting longer-term extras that we want to do, right? So single secret leader election basically means that like you make the who is going to be the proposer of the next block more unpredictable. And the purpose of this is to like protect against DOS attacks, right? So with SSLE, you're not going to be able to tell who is going to create the next block until they actually release the block, which is really amazing, right? Because that basically, it gives us really nice security property where like if you're an attacker and you want to stop blocks from being created, you don't know who you have to attack. Single slot finality. It used to be called single slot confirmations. Now we're just calling it single slot finality. Basically, moving to a world where Ethereum can actually confirm blocks within a single slot. This is something that I have been kind of looking into and talking about for probably the last half a year or so. There's a lot more work on it happening. One of our researchers, Francesco, has also done a lot of work, and there's a lot of interesting stuff being done by consensus researchers on trying to figure out the best way to do this. But it's like actually more possible than it seems, which is interesting. And then better signature aggregation, that's actually kind of part of single slot finality, right? So there's a lot of stuff to do in proof of stake. The end state of all this will be a proof of stake mechanism, which is really great. But in order to get there, there's like all of this work that needs to be done. The surge, sharding, right? This is basically, I think before we wanted to do 4488, we decided that we would like to rearrange the numbers a bit. So instead we're doing 4844, which is proto-dank sharding, basically trying to kind of lay the groundwork for doing full sharding, kind of have all of the data formats in place, and also at the same time adding like at least a little bit more data space that rollups can use to make rollups much cheaper, right? Potentially some, could even be something like 10 times cheaper. That's like the proto-dank sharding. Then after that, we want to do dank sharding, which adds data availability sampling, and then we want to do like other things around just increasing the amount of space that we have, some kind of like faster confirmations, so that Ethereum could have not just greater scalability, but also like lower latency, and at least until you get some degree of confirmation that your transaction got included. So just a lot of like interesting things, at the end of which Ethereum will be a far more scalable system. Ethereum today can process about 15 to 20 transactions a second. This Ethereum, including the rollups, including the sharding, if at least according to the math, it's going to be able to process 100,000 transactions a second, and hopefully there's going to be a lot of other benefits that come at the same time, right? The Verge, stateless clients, so you will be able to verify Ethereum blocks and even be a validator without having hundreds of gigabytes on your disk, which is so great for decentralization. The Purge, trying to actually cut down the amount of space you have to have on your hard drive, trying to simplify the Ethereum protocol over time, and not requiring nodes to store history, and then just like this big long list of things, right? So there's this big long list of like really fun stuff that will make Ethereum into a much more powerful system, a much more robust system, a much more secure system, and even a more decentralized system, but it's a long and complicated transition. There's a lot of stuff that's happening. Like each one of these boxes basically like, has like some kind of team associated with it at this point. So a lot of work that needs to be done, right? So the difference between Bitcoin and Ethereum is that Bitcoiners consider Bitcoin to be 80% complete, but Ethereans consider Ethereum to be 40% complete, right? This is like, I think actually something that I've said a couple of times before. And when you look at what Ethereum is trying to accomplish, it's true, right? Like the Ethereum protocol is like really still trying to fulfill this role of being some kind of secure base layer, but trying to do so in such a way that like it actually has the functionality that it needs to be a secure base layer for the stuff that people actually want to do, right? And that does involve adding more features. It does involve doing more work, but at the same time, kind of there is also still this kind of this end goal, but we're a bit further away from getting there. I'd say Ethereum can go up to being 55% complete after the merge. So we're getting close. I think we're getting close to kind of the second half of this kind of big long vision, right? Which is really amazing, and like all of the people that have been working hard to make it happen should be super happy at this point. So completing the transition involves deep changes, right? It involves deep changes, and I don't just mean like deep changes that people who write code have to care about. I mean deep changes in how people think about the Ethereum protocol and kind of conceive of the properties that the Ethereum protocol provides, people who interact with Ethereum. So monetary policy, right? So the switch from proof of work to proof of stake is going to decrease issuance from 5 million a year to this kind of weird math equation that's like 166 multiplied by the square root of the total deposits. So if there's 1 million ETH staking, it's 166,000. If there's 100 million ETH staking, it only goes up to 1.66 million. So in all cases, it decreases by a lot, right? It's not fixed anymore, but it's much lower than it used to be. So monetary policy is changing. Security model is changing. So proof of stake is much more secure than proof of work, but it does have its trade-offs. And this concept of weak subjectivity is one of the big trade-offs of proof of stake. And this is something that I've talked about a lot. This is something that we've talked about a lot. This is something that Ethereum researchers have already built a lot of tools around measuring, but it is a change to the security model. Data availability sampling. So this is the idea that you can literally have a blockchain run without needing even a single node to process the entire chain, which is something that, like, from a blockchain point of view is very fascinating and mind-blowing, but from a kind of broader distributed systems point of view, it's like totally common sense, right? Like, nobody would even consider building a version of BitTorrent where everyone has to download every movie, right? But that's how blockchains work today. So trying to kind of combine the actual distribution that you see in peer-to-peer networks, where you actually have like different parts of the network responsible for different parts of the data, with the security properties that blockchains provide, right? Like, this is basically what Ethereum is trying to go towards, and that does include some changes to the security model. Layer 2 history access. So a lot of dApps that are built on Ethereum historically, they've relied on this assumption that you can use things like history access and you can look at historical logs, you can look at historical transactions, and the dApp from like you directly using the Web3 protocol would be able to just like tell you the entire history of everything related to you that happened in the dApp, right? And this is something that has been true for Ethereum's history, but it's something that's not going to be true anymore. And the reason why it's not going to be true anymore is because of EIP 4444, right? Basically, with EIP 4444, moving toward a world where this function of accessing and restoring and retrieving all of the entire history of Ethereum is not going to be a kind of core requirement of an Ethereum node anymore, right? And the reason why it has to be done is basically because people value scalability. And if we want scalability, if you want decentralization, so like the ability to run nodes easily, then you just can't require nodes to store this kind of constant, ever-growing amount of space. Now, there are alternatives, right? So there are plenty of like very secure, very decentralized ways to store the history that do not involve requiring every single Ethereum node to store the history. So there's like second layer protocols, things like the graph. There's work that's being done by people in the Portal network. There's work that's being done by some other groups. There's people trying to kind of upload part Ethereum history to BitTorrent. There's block explorers, of which there's like a bunch, and you can probably make a multiplexer that just like keeps on asking each one of them. And you can even make a protocol that like asks them for proofs to make it more secure. So there's lots of alternative ways to access history, but that's not going to be like something that the Ethereum protocol itself is directly responsible for, right? So that's also a change to the security model. Now, it is a change that I think dApps have already mostly adapted to. Like if you use dApps today, and they access history, most of them are not going to use like the Web3 API directly. Lots of them already use the graph, right? So this is something that I think the ecosystem is already adapted to, but it is a change that is a kind of a necessary part of Ethereum becoming more decentralized and more scalable. New cryptography. So the Ethereum of 2015 relied only on Keccak hashes and elliptic curve cryptography for security, right? Just those two ingredients. The Ethereum of 2023 is going to rely on that, plus more complex uses of elliptic curves with things like Verkle trees, if they come in 2023, it could be 2024 as well. Also elliptic curve pairings, which is a more complicated form of elliptic curve math, which the beacon chain already relies on. Some like universal trusted setup for data availability sampling, and potentially like some. Eventually, the randomness is going to be augmented by VDF as well, right? So there's also like some new cryptographic assumptions that are being introduced. And these new cryptographic assumptions give us a lot of really massive benefits, right? So like the Ethereum of today that uses BLS signatures that rely on pairings, that allows us to have hundreds of thousands of validators, which allows us to let people stake if they directly with a minimum of 32 ETH. Does anyone remember what that minimum was before we decided to use BLS? It was 1,500, right? So we added a security assumption on new cryptography, and the benefit is that staking became 50 times more accessible. So basically, there are very real benefits that are going on, but also like real changes here. The transaction inclusion process. So EIP 1559 happened last year. It was amazing. It changed a lot, but it also changed a lot about how we have to think about including transactions. Account abstraction. Basically, people being able to send transactions that are verified not just by elliptic curve signatures, but by like whatever kind of algorithm they want. So you could have better multisigs, better smart contract wallets, better social recovery wallets, move to other algorithms. Potentially, with account abstraction, you could also have signatures that are much smaller. You can use signature aggregation. And this is really powerful in rollups because so the ERC4337 team, this is the team that's working on the account abstraction of ERC right now. they've been starting to do this, and with a signature aggregation, you'll basically be able to remove the 65 bytes from every transaction that are the signature and replace it with just 65 bytes for an entire block, right? So potentially rollups could become 3 times cheaper if this is all implemented, right? So a lot of like proposer-builder separation could also change how transaction inclusion works, right? So there's a lot of things that are happening and a lot of things that have big and important benefits, but that also require kind of changing how we think about certain things, right? And it's also involved building a much stronger and a much more capable research and development ecosystem that's capable of coming up with these changes, testing them, making sure that they actually do what they need to do, implementing them across 5 clients, making sure they're implemented the same way across 5 clients, making sure there's no bugs, and doing that entire pipeline and actually getting them to production, right? So there's a lot of stuff happening, but, and this is where I get to kind of the more cautionary part of the talk, that doesn't mean that we should keep going this way forever. Okay, so basically, I think, so this is, I think, both my preference and also my impression of something that a lot of people want for the Ethereum protocol, which is basically for a desire for Ethereum to kind of eventually settle down, right? So right now, I think we're entering into this kind of period of rapid change where the capabilities of Ethereum are increasing rapidly. Right, so you know, we got EIP 1559. We're going to get a switch to proof of stake. We're going to get vertical trees. We're going to get single secret leader election, and we're going to get EVM improvements, and all of this is really cool stuff. But at some point, the rate of change of the protocol is going to have to again slow down, right? And like basically, it doesn't necessarily mean that kind of Ethereum ossifies completely, but it does mean that it does kind of look somewhat more like a system that optimizes for safety and predictability, and less like an ecosystem that optimizes for impressing and dazzling people. So why settle down? And by the way, these are QR code links to kind of articles where I talk about some of these things in more detail. But one reason is the layer separation vision, right? So this philosophy that layer 1 is for security and dependability, layer 2 is for rapid iteration, action, high scalability, extremely fast response times, like good features for users, and all of these different things, right? And the theory is that we can get basically the benefits of both at the same time, and the way that we do that is we have this underlying safe and secure L1 that focuses on safety and security, and that focuses a kind of not on a kind of outmaneuvering kind of everyone else, and not on kind of doing everything else as quickly as possible, but on surviving, and you know, on surviving much longer than like things like Luna do, right? So the layer 1, you know, really needs to optimize for being safe, and layer 2 can optimize for like actually doing really amazing and impressive stuff. And layer 2 has been doing amazing and impressive stuff, right? Like there have been all of these ZK EVM announcements that we saw over the last couple of days. There's a lot of work that's being done, you know, by both the Optimistic and the ZK teams. Like Optimism has added compression. Arbitrum has been kind of quietly progressing and just you know, becoming more stable and adding features. You know, Starknet has been recently made their kind of announcements, and we're starting to see more and more, you know, what kind of a network Starknet is going to shape up into being. And there was just a lot of amazing work that was done on Cairo there. You know, ZK Sync is going forward, and you know, Polygon, ZK Rollup. So you know, scroll this kind of big long list of teams that has been just doing all of this amazing work, and that like really has been kind of rapidly iterating and acting. So the reason I think behind this idea is the functionality escape velocity thesis, right? So the functionality escape velocity thesis basically says once L1 is strong enough, the rest can be done by layer 2. right? So this kind of vision of simple, boring, slow L1 and like fast action L2 is a good vision, but it requires L1 to be good enough to actually support it, right? It's kind of similar to Turing completeness, where if you have a computer that's powerful enough, then it's powerful enough that you can build basically anything on it. But if the computer isn't powerful enough, then like very quickly it turns into a machine that can do almost nothing, right? Like in terms of what you theoretically can do on a computer from 2020 and say 1990, the difference isn't too large, right? It's just a difference of like what's the level of like scale that you can and the level of performance that you can achieve. But if you look at the difference between an early computer and say a pocket calculator, well, the difference is fundamental, right? It's like no matter how many billions of years you have, with a pocket calculator, you can't make it run Minecraft. With a computer from 1990, you can, right? And basically, the functionality escape velocity thesis says that there's something very similar like this for blockchains, where blockchains have to provide this basic set of ingredients. So enough data for rollups, rich statelessness, so you can do a kind of logic around like things like either snarks or fraud proofs. Some kind of basic censorship resistance functionality, having an asset, like this kind of fairly basic list of things that Ethereum already provides a lot of, but it doesn't quite yet provide 100% of, and that big long list of features that we're looking at adding in is in some ways about kind of filling that in, right? And also developers need a break, new features need time to de-risk, and like basically, once you start working less hard on kind of making features go up, you can actually start working harder on doing other things that are very meaningful in other ways. So one of the trade-offs in doing this well is there's this trade-off that Ethereum has of complexity of the change that's being made versus the complexity of the final result, right? And this is one of these kind of very subtle points where basically there are a lot of opportunities that are kind of short-term pain and long-term gain. So what do I mean by this? Banning self-destruct, right? So this is one of the kind of things that I've been pushing for a long time. It's one of the things that I think a lot of the core developers have been pushing for a long time. Basically, the self-destruct opcode is just, one, not actually that useful, and two, it's uniquely bad in terms of like how much complexity it adds to the EVM and to implementations of the EVM and to the difficulty of making other kinds of changes to Ethereum. And so if we just remove that opcode, that's actually a very significant gain in simplicity, but it does come at the cost of breaking backwards compatibility for a very small number of applications. Reforming how gas costs work around child calls, around memory, just like the way that gas works today is in some ways needlessly clunky in a lot of cases. It's both too complicated and too kind of overfitting to very specific situations. EIP 4444, so this is no longer requiring Ethereum clients to store the entire history. EVM improvements, so the EVM object format EIPs that try to kind of like allow you to add other sections to EVM code. A switch to Verkle trees, and what comes with a switch to Verkle trees is some other changes to how gas rules work, right? So there's a lot of these opportunities that add functionality and that even increase the simplicity of Ethereum, right? So Ethereum, after you go through with all of this, actually becomes a system where like the number of lines of code you need to have in a client and even in the spec actually decreases over time, right? Which is amazing. But in order to actually have all of these benefits, like, you have to go through short-term pain. Now, what do I mean by short-term pain? One is that the features have to be implemented, right? Another thing that I mean is that there are a couple of like applications that are designed in just like ways that are uniquely unfriendly to some of these changes, and those applications will just have to change how they work, right? Now, this is, of course, something that should only be done with a kind of very long lead time, right? So to make sure that everyone who's going to be affected by it is aware of it, everyone who has an application that like really depends on exactly how things work now has the opportunity to change to something else. But once it's done, this is an opportunity to do something where there is this kind of pain that happens once, but then basically future generations will be very thankful that there aren't these kind of annoyances that people have to keep on coding around and thinking about forever. So the ideal long-term goal here is basically that kind of the total complexity of Ethereum. So not the same thing as the level of capability, right? So the level of capability goes up, but the level of complexity, like we're here, we're still adding complexity, but I have this hope that the level of complexity at some point can even start to go down, right? Now, why would it go down? Because of some of these simplifications. Also because Ethereum clients would not necessarily have to keep on supporting very old versions of the Ethereum protocol. After the merge, you could even build an Ethereum client that just completely does not know that the proof of work phase ever happened, which is like a huge simplifying factor in a lot of ways, right? So there's a lot of ways in which complexity of the system can go down over time. So in the short term, some of this does mean breaking backwards compatibility in a few very, very limited cases, right? It's like really a very small number of cases. And like one of my claims here is that that is okay, right? That is like basically, you do need, like at some point an ecosystem does have to be willing to do these kind of short-term pain and long-term gain trade-offs, but an ecosystem also should not be in this kind of mode of like changing things rapidly forever, right? So short-term, still in rapid change mode, but longer term, at some point you do need to kind of have this pivot to in an ecosystem where change is less rapid, even more consensus on everything is required than today. Things do keep moving even slowly, and that does look very different from the way that Ethereum works now. So things in particular that I would be scared of doing, right? So things that I think we should not do. One is adding support for multiple VMs. So simultaneously support EVM and EWASM and Cairo and other stuff. The reason why you don't want to do that is because that just multiplies consensus complexity. Like getting rid of the EVM is too hard, and so if we add stuff, well, we're going to have like 3 different VMs, and the number of lines of code in the protocol is just going to, keep on blowing up forever, right? Getting comfortable with base layer snarks before we have much better circuit legibility, right? So before we really have the tools to kind of dig into ZK snark circuits and be able to properly understand here's exactly what's going on at each individual constraint, right? So basically, my opinion right now is that snarks are still a bit too black boxy, and hopefully they're going to become less and less black boxy over time, which is something that's that would be really amazing. But I personally do think that something like that is a prerequisite, right? We want to make snarks more understandable before we make the Ethereum base layer itself actually depend on them. Also, I personally am scared of surrendering to this idea that it's okay if no single person can understand the Ethereum protocol because we can specialize. I think part of Ethereum being a trustless protocol should actually be Ethereum being a simple enough protocol that if you really wanted to wrap your head around the entire thing, you should be able to, right? And that is in some ways very kind of constraining, and that does imply a layer 1 that has less kind of dazzling bells and whistles and less functionality in a lot of ways. But in my opinion, I think if the goal is to create a layer 1 that's kind of maximally robust and maximally dependable, this is something that I would say is worth it. So what are other awesome things that I think that we should actually increase our focus on over time, right? So these are things that I think we need to start working on today, and we have started working on today. But things that where basically once the level of effort involved in increasing capability starts decreasing, the level of effort involved in making all this other stuff happen can start actually going up, right? So one of them is an easy to use light client for the Ethereum consensus layer and the execution layer and layer 2s, and for such a thing to be a default, right? So basically I want to see a world where instead of the default, instead of a new Ethereum user by default using MetaMask that plugs into Infura, I want them to would like to see a world where they can use some wallet that actually is a light client that directly uses decentralized protocols to plug straight into the Ethereum network, right? And for that to happen, both for base Ethereum and for layer 2s. So also for Starknet and Optimism and ZK-Sync and Arbitrum and Scroll and all of these, and Polygon as well, to also kind of somehow plug into the system, and so you can actually directly have light clients that can access and directly verify all of these systems. Better support for home stakers, and better support for like smaller scale decentralized staking pools, right? So even for people who need staking pools because they don't have 32 ETH, or they don't have like whatever the level of ETH is that's going to be required, still better give them better ability to like join a smaller scale pool that doesn't involve joining one of the big ones. Also, the ability to run a full node on lighter hardware. I think this is something that, especially once we have more ZK snarks, can easily improve over time, right? Like, so once we have stateless clients with Verkle trees, it'll improve a lot because you're not going to need like 500 gigabytes of hard disk space anymore, right? Like post Verkle trees, it should be possible with a well-designed client to just run everything entirely in RAM, right? Like it should not actually require that many gigabytes. Now, potentially being a validator might require storing other stuff, and it might kind of go up a little bit beyond that, but hopefully not too much. You know, like I personally still want like mobile phone staking to be eventually possible. So like basically how far can we go on like making the entire Ethereum ecosystem like actually meaningfully decentralized, meaningfully reduce dependencies on kind of like single actors, meaningfully reduce privacy risks that come from dependence on single actors, and just actually make the Ethereum network kind of resilient in the way that I think a lot of people want it to be. So pursuing decentralization goals is harder today because the protocol changes quickly, because the total complexity is getting higher. But in a protocol that is simpler and in a protocol that is slower changing, I think pursuing more decentralization is actually something that does become easier. So I do think that there are changes that are worth making in the long term, right? So like I personally am not predicting that the Ethereum network is going to become something that undergoes literally zero change. And like here's some examples that I think are actually worth it. Upgrades from quantum resistance. Quantum computers, there's a big chance that they're eventually going to come. And once quantum computers come, we have to upgrade to different cryptography, right? So can't use elliptic curves, can't use pairings, can use hashes, can use Starks, can use lattices, right? Can use isogenies. So that basically once quantum computers come, we are going to have to kind of get used to using different tools, which is obviously something that the ecosystem will have to learn its way around. It is something that will involve some sacrifices, but it's something that just has to be done if we want Ethereum to be secure. If ZK VMs work well, increasing transaction space in the base layer. So if once we have good circuit legibility and we have very good ZK implementations that can snark verify the EVM, then that's something that could be applied in the base layer. You could start adding more transaction space. You can start using more data space or more of this data availability space to add transaction space. So things could be done there. If much better cryptography comes out that lets us massively improve efficiency and simplicity, we should use it, right? So today, I'm advocating, and a lot of people have been advocating, for Ethereum to switch from hex Merkle Patricia trees to Verkle trees. Maybe in the future, just hashes and arithmetically friendly hashes are going to be de-risked enough and are going to be friendly enough that we're going to want to actually give up on Verkle trees and do Stark proofs of arithmetic-friendly hash Merkle trees instead. If that happens, then I think we should do it. And also, I think we should keep an open mind, right? We don't know what the needs of 2032 are going to demand. So one example of this is the whole MEV situation, right? The centrality of MEV as this issue that the Ethereum protocol needs to really build and work around, that's something that we weren't really aware of back in 2019, and we became aware of in 2021, and now it's well understood, and it's part of how we think about the Ethereum protocol in 2022, right? So there could be other things like that in the future, we might have to think in some different way about how to deal with 51% attacks. So you might have to think about adding other kinds of features to ensure staking decentralization, right? There are more things that could happen. There are always unknown unknowns, but At the same time, like that number of unknown unknowns is something that I do think should decrease over time, right? So basically the challenge here is, how do we balance all of these different demands? Like I think in the short term, we are in this kind of environment where it's just unavoidable that all of these rapid changes that are going to produce all of these really important things that Ethereum people have been looking forward to for a long time are going to have to be done, right? Like people have been looking forward to proof of stake for a long time. Who here wants to cancel proof of stake? I saw one person try to raise their hand and then lower it for fear of getting canceled. No, please. If you want to cancel, proof of stake, we're not going to cancel you. We're just, there are plenty of blockchains. Like there is Ethereum Classic, which is, the original Ethereum, which did not betray the vision by forking the DAO. It's a very welcoming community, and I think they'll definitely welcome proof of work fans. So. No, it's not even a joke. Like, if you like proof of work, you should go use Ethereum Classic. It's a totally fine chain. But anyway, so proof of stake, lots of it's a big change, but lots of benefits. Sharding, right? So anyone here want to cancel sharding? Okay, not too many. Okay, I see a couple of hands that raised a little bit more confidently, right? But I think, in general, I do think that sharding is popular because people do realize that, in order to fulfill the Ethereum vision, we actually want to have much lower transaction fees, and we actually want to be able to support, 50,000 transactions a second somehow. And, if it's not done in a way that's decentralized, it's going to be done in a way that's centralized, right? So. Sharding is important, right? So there is this balance, right, of what needs to be done and what kinds of things can we just leave to layer 2. And so in the short term, there's all of this kind of stuff that I do think needs to be done, but in the longer term, there is also this challenge of shifting down the gears again and actually also settling into this newer normal of Ethereum actually being this kind of dependable system that at some point is only going to change very infrequently. That's going to be a transition. I expect it's going to happen at some point, but what that's going to look like, we'll see. And I think this is also something that all of the different parts of the Ethereum community really needs to kind of pay attention to. It's kind of being part of kind of figuring out what this longer term Ethereum will look like. That's something, it's not even just for core developers. It's also there's lots of things that people just anywhere out there in the ecosystem can do to contribute to this. There's lots of things that just people out there in the community, even people out there in the application layer can do to kind of contribute to this, right? Make sure that your application continues to work and even works better in a world where the Ethereum protocol is kind of upgraded in a bunch of ways. At the same time, also the layer 2 teams, right? If layer 1 is going to slow down its rate of change at some point, then to the extent that change is still required, the layer 2 protocols are going to have to pick up the mantle. And I think our layer 2 ecosystem is great, and it's going to keep becoming even greater. So thank you. Thank you.